we are programming with C++. My name is Franco Furious. So now an overview of the C++ language. So now our objectives is to introduce to C++, learn why we should use C++, learn object-oriented programming, then also learn standard library components like output or input stream. So now our objectives are to understand the program, that's the C++ program. So now C++ programming language, it was created by Benjamin Stroup in 1979. It was formerly called C with classes. So at that time it wasn't called C++, it was called C with classes. So now C++ was coined by Rick McZitti in 1983. So C++ was evolved from C. So now why we should use C++? Because it is used in everyday computing system. And C++ has object-oriented programming. Object-oriented programming simply means it allows developers to organize their code into reusable objects. So object here simply means that to combine data and operations on the data into a single unit. So that's the meaning of an object. So C++ is a compile language. Simply means that it needs a compiler to translate the code written in high-level language into the machine language. The machine language simply means the language the machine understands. So C++, for example, is a high-level language. So now let's move on. So why C++? As you said earlier, it was created by Benjamin Stroup in 1979. So now object-oriented programming. So we identify components called objects, then specify relevant data and possible operations to perform on that data. So as you said earlier, object combines data and operations on the data into a single unit. So now programming language that implements OOD for short, it means object-oriented design. So when you talk about object-oriented design, it's a design approach that focuses on defined objects and their interactions to solve a problem. So that's the definition for the OOD, that's object-oriented design. So now a programming language that implements that object-oriented design is called an object-oriented programming language. So as we move further, we will learn how to present data in computer memory, how to manipulate data, and how to implement operations. Then write algorithms and implement them in a programming language. So algorithm simply means a step-by-step approach to solve a problem. So now we learn how to combine data and operations on the data into a single unit. So as I said earlier, that's an object. So C++ was designed to implement object-oriented design. So now data abstractions, that is the creation of classes to describe objects. Data encapsulation for controlled access to object data. Then inheritance is by creating a derived class. Polymorphism is the implementation of the instructions that can have firing effects during program execution. So now this is a simple structure of the C++ program. So we have a hash include, that's the preprocessor. Yes. Then IO stream is input to output stream. Then using namespace std int main. It means that every C++ program must have a function called main. So the main is a function. Then you have your output, so cout together with the insertion operator, then your statement, then you terminate, or you can say end L. That means that move the cursor to the next line. Yes. And then you terminate, then you return 0 for successful execution. So now to execute a program written high-level language such as C++. So C++, for example, is a high-level language. So now we use an editor to create a source program in C++. So you need an editor to write your code, your program. Then in C++ program, statement that begin with hash include, or let's begin with the symbol hash, are called preprocessor directives. So let's come here, for example. So hash include, so it will start with hash. So the hash include is a preprocessor directive. Yes. Yes, it's not easy. Preprocessor directives. Yeah. So these statements are processed by the program called preprocessor. So we use a compiler to translate the program written in a high-level language to the machine language. Mhm. So now when you see a linker combines object programs with other programs provided by the SDK to create executable code. So now the loader, the function is to load executable programs into the main memory. So the last step is to execute the program. So now there's a simple diagram for it. In a C++ program, you need an editor to create your source code. You need a preprocessor, and it begins with hash symbol. Then you need a compiler to translate the code you've written into the machine language, the language the machine understands. The linker combines object programs and other programs provided by the SDK to create an executable code. You need a loader to load the executable program into the main memory. Then execution takes place. So now to run code through the compiler. So if the compiler generates error, look at the code and remove that error. That means that you go back to the code and look for the error, then you do something about it. So when you run the code again to the compiler, then there's still error, still go back and go and check. But if there's no syntax error, there will be a successful execution. That's like correct execution, successful, yes. So once compiled and linked, the loader can place program into the main memory for execution. So once it's compiled and linked, the loader now, its purpose is to place the program into the main memory for execution. So the final step is to execute the program. So now when you talk about process, it's a program loaded into the main memory along with all resources needed by the program. So each running instance of a program is a process. So each process runs independently. Yes. So a thread, it simply means a unit of execution within a process. Yes, it's simply a unit of execution within a process. Yes. So multiple threads can be initiated from a single process. So now there's a diagram of the thread. So now a program starts out as a test file of programming code. So the program is compiled or interpreted into binary forms. So the program is translated into a machine language as in binary form. And the program is loaded into the main memory. Then the program becomes one or more running processes. Then processes are typically independent of one another. So thread exists as a subset of a process, and thread can communicate with each other more easily than processes can. So this is where we end our first lecture. Thank you for listening. My name is Frank Kofi. Thanks everyone for your time and your patience.